Hey guys, we are going to be in chapter 5. We're looking at chapter 5, section 5, and we're going to look at absolute values in the context of inequality. So, inequalities involving absolute value. No vocabulary fortunate for us, so we're going to get straight down to examples. This example is kind of a made up example, it's not found in your text. I just want us to think through it. The concept of absolute value and how it's associated with inequality. So let's get started. If you look at this inequality, it says the absolute value of some number x is less than 3. All right, I'm going to make this into number lines. That's my intention here. And I'm going to number this like that. So now that I have my numbers on the number line, I want us to think, I'm going to put some red dots on this graph. I want us to think of what numbers on this number line would satisfy this inequality. So 0 would, right? Because 0 is less than negative 3, absolute value. 1, negative 1 would, 1 would, because if I put 1 in for x, it is less than negative 3, negative 1, that's true. Pretty much all this stuff in here is going to work, right? In fact, everything up to 3, because if I put 3 in here, 3 is not less than itself, everything up to 3 works. Nothing above 3 works here. Let's try this other side. If I go over this way, everything, yep, to negative 2.5, all that works up to negative 3. As soon as I put a negative 3 in here, the absolute value of which is 3, is not less than 3. So my answer, my solution is this. I hope that this, you think of this and you're looking, you're like, this looks so much like the last section where we would write the inequality that represented this graph here as x being somewhere between negative 3 and 3. What I want you to recognize is that this is this. All right, these are exactly the same thing. So the answers that would solve, or the solutions that would work here, are found right in this interval. Another way of looking at it is when I look at this problem, these x values, their distance from 0 has to be less than 3. Their distance from 0, so if I think 1 is, its distance from 0 is less than 3, up to 2.999, its distance from 0 is less than 3, and same thing in both directions. So we can also look at this as x minus 0, right? The distance, the difference from this number and 0, the difference or the distance from 0 is less than 3. We're going to do a similar thing here. I'll use blue just to be fancy. So here, if I do the same thing, let me get a number line. Okay, so there's my number line. And if I consider the values that are going to work for this particular inequality, notice that the absolute value of x is beyond or greater than 3. We could also think about this as the distance of x from 0 is greater than 3. What values work? Well, 0 doesn't work because that distance from 0 is not greater than 3. Or if I put 0 in here, 0 is not, the absolute value of 0 is not greater than 3. If I continue to go out here, I'd see that all of the answers that I'm looking for have to be beyond 3, right? Because 3.1, if I put 3.1 in here, the absolute value of 3.1 is greater than 3, yay! So I've got it. But there's also another set of answers that work. And I hope that you guys see this. All these values that are less than negative 3 work. And you may remember that this is an or situation. And so what we would write here is that x is less than 3 or x is greater than 3. So this is the same thing as this. All right, so I want you to hold on to this when we look at some of the examples, and I talk about shortcuts that are not in your textbook for solving some of these inequalities. All right, so let's take a look at the following problem. So here, we're going to solve an absolute value inequality. And I want you to notice that this inequality is going to match, let me use red, our red example, when x, the absolute value of x was less than 3, right? The absolute value of x was less than 3, and we talked about this being the distance from x minus 3. The distance from 0 has to be less than 3. As I look at this problem here, I'm going to solve it with this in mind. Do you remember that x had to be between 3 and negative 3? That's what we said on the last page. We're going to solve this with that in mind. When we have the inequality symbol in this direction and our absolute value symbol on the left side of it, we are going to write this as m plus 2. This thing has to be between 11 and negative 11. I'm going to just sit here for a moment and kind of over talk this again. Look, do you guys remember when we said the absolute value of x was less than 3? We knew that that meant between this thing was between negative 3 and 3. Similarly, the absolute value of m plus 2 is less than 11 means that the answer to this is between negative 11 and positive 11. So with that in mind, I'm just going to solve this compound inequality as I have here. So let me make sure I have what I need. So I'm going to get rid of this plus 2 by subtracting 2 on each portion of my compound inequality. And I end up with negative 13 is less than m, which is less than 9. So my answer, m, has to be between negative 13 and 9. Okay, so let's pick up with this next example as we consider the absolute value of y being less than negative 2. I'm going to say that again. The absolute value of y minus 1 being less than negative 2. Before you have a knee-jerk reaction of just going about the way we solved the last problem and similarly doing this one that way, what you want to do is really observe what's going on here. We're saying that the absolute value, which we know to be a positive value, is going to be less than a negative 2. That doesn't make sense. So you want to make sure that before you even start your problem that your inequality makes sense. In this case, there is no solution that could make this true. There's no value of y that I could place into this inequality to make this true. So the answer to this is no solution. And we could also write this as the null set. There's no way that that's going to work out. Let's take a look at some more examples. Here in example 3, we're going to apply the absolute value inequalities. I kind of didn't want you guys to see this, so I'm going to pretend like this is not here. Boop, doop, doop, doop. All right, it's gone. So here's what we're going to do. We're going to just read and see if we can set up the situation to figure out how to answer it. A survey showed that 65% of young adults watch videos on YouTube. The margin of error was 3 percentage points. Find the range of young adults who watch YouTube. When we talk about margin of error, it means that with any poll or any statistical information, there's a margin of error based on the number of people who actually took the survey. So in this case, the margin of error is, oh, nice, that's awesome. I'm sorry. The margin of error is plus or minus 3, right? So it's 65%. But we could be plus or minus 3% off. That's what this is saying. The percentage points, 3 percentage points. So it means it can go in either way. You guys can intuitively add 3 onto 65 and subtract 3 onto 65 and come up with the margin of error. But we're going to use inequalities to do this. Not the margin of error, but the range that the young adults that watch the YouTube, the percentage range, I should say. Over talking. Anyway, so here's what we're thinking about. The difference, x, between the actual number. So if we think about the actual number of students or young adults who watch YouTube, if I subtract that, if I find the difference between the two, right, the positive difference between the two, it would have to be what? What does this equate? What is this information telling me? It's telling me that the margin of error is within this 3 points. So it has to be less than or equal to 3. And that's what that equation was that you saw before, right? So that's what I was trying to hide. So the difference between, so in this case, x is the actual value, the actual number of young adults, YA, who watch YouTube. All right, that's the actual value. The difference between that and 65 is 3%, is between 3. So it's a similar thing that we're talking about, but it's a different way of looking at it. And so since we recognize that this is one of those problems that we had before from example 2, we know that we can solve this by saying, well, this value is between 3, positive 3, and negative 3. So I write it as negative 3 less than or equal to, x minus 65 less than or equal to 3. What I want you to notice is that I basically rewrite this, put the same symbol facing the same direction here, and put this number over here, but change the sign. I'll say that again. I leave the center part alone, except I take off the absolute value symbols. Boom. I put the 3 here. Boom. I take this exact symbol, copy it, put it right here, and then I put a -3 here, and now I'm good to go. I'm going to actually solve this. So I'm going to add 65 to both sides, all 3 sides that is. When I do that, I end up getting what you guys intuitively thought of in terms of adding 3 and then subtracting 3. That's really what I'm going to do. So 65 plus 3 gives me 68, and then when I subtract, and I need to put that there, and when I subtract that 3, I get 62. So the actual value, the actual range is somewhere between 62 and 68% of young adults who watch YouTube. Let's take a look at, I think this might be the final example, example 4. Example 4, we're going to solve absolute value inequalities that are like this. So this is reminiscent of the example that we had, the second example we had, the second part of the example in example 3 that we had like this. Yeah, so we had this, and do you guys remember what happened back then? We realized that x was either greater than 3 or x was less than 3. We had what I sometimes call a disjunction, or we had what we refer to as a union. There's 2 different pieces that we're bringing together. So when we have situations like this, I want you to know that this is going to be the result. Let's watch. Remember, I said just write down the center part, 3n plus 6. Put the same symbol on either side, and then put the positive, the 12 here, and then -12 on this side. This is now an inequality that we can handle. However, if I read it from left, this was cool, but when I read this new production, this new thing that I created from left to right, there's something fishy going on. Can -12 be greater than 3n plus 6, and then at the same time, 3n plus 6 be greater than +12? No, that confirms the fact that this is a disjunction. So I write -12 is greater than 3n plus 6, or 3n plus 6 is greater than or equal to, I should have had equal to here, 12. And then I'm going to just block this off. I'm going to finish solving part A. So I'm going to add 6 to both sides of this part of the equation. Add a -6 to both sides. I get -18 is greater than or equal to 3n. N is less than or equal to -6. And that's one part of my answer. The other part is I'm going to get from this portion here. So if I go ahead and subtract 6 on both sides, 3n is greater than or equal to 6. N is greater than or equal to 2. So, because I'm dividing both sides by 3. You guys got that, and over here I divided both sides by 3. With that in mind, I get a disjunction. I get 2 separate parts of the graph that are going in their own direction, and I mean, that's just what it is. There's really no other concise way to talk about that, but let's graph the solution set. When I do that, I'm going to go to my +2, fill that circle in, shade to the right. Then I'll go to my -6, fill that circle in, and this is less than, n is less than, it's on that side. I'm going to shade to the left, and I get that situation. Our final example, I'll do in red, r minus 5, the absolute value of which is greater than or equal to -2. If you take a look at this carefully, you'll see that this is another kind of trivial wild case that doesn't tell us much, because the absolute value of something being greater than or equal to -2, yeah, pretty much everything is greater than or equal to -2 when we have the absolute value sign around it. And so the answer to this, there's really no work. It really is about being a student, paying attention to your to the information given. The answer here is all reals. And you know how I get. I'm going to ask you guys to do R such that R is an element of the reals. And that's our super cool, fancy, mathy way of saying, yeah, all reals. Any old number's going to do. All right? Guys, I hope you have an excellent day. I hope this made sense. Feel free to ask me questions, because this is kind of a topic that sometimes gets a little bit confusing, but there's some real surefire ways of making sure that you can handle it successfully. I look forward to talking to you soon. Bye-bye.